This is the proposed Mall of Asia to Edsa Taft aerial cable car line. This is Part D, part of a series of videos that will be devoted to this line. Higher capacity monorail. SM may have intended the MOA to Edsa Taft monorail line to be a high capacity line. The MOA monorail station will additionally serve the mass transportation needs of the SM reclamation islands at the back of MOA. The route of this monorail line will likely go to the SM islands. This figure shows the alignment of the possible additional monorail line that will connect MOA to the two islands. SM monorail data shown on the internet does not indicate the capacity or number of train coaches that one monorail train set will have. If the SM monorail line is intended to have a high capacity of more than 4,500 pph PD, then the train set needs to have more train coaches. An example is this high-capacity monorail in Chongqing, China. Cable-propelled transit manufacturers have a simple counterpart rail-based mass transport system that can provide a similar capacity. It is called a cable liner. The train set is attached to a cable underneath by means of a clamp. The clamp is released upon arrival at the station. It has similar advantages as that of ART over a monorail. This type of transport system is discussed more in detail in other chapter videos. Current installations of monorail versus ART. This table shows 21 existing urban monorails in the world since it was first installed in Seattle, USA in 1962. Some urban monorails installed since 1962 that are not listed here have been dismantled for lack of profitability. Adjusting for distance and number of stations to make an apple-to-apple comparison, the La Paz ART outperforms all of them in terms of ridership. Its daily ridership is 300,000. Being installed only recently, the ART ridership is expected to increase in the coming years. This will further extend its lead. Businesses are continually sprouting or flourishing around the 26 stations of the La Paz ART. Its potential to accommodate more ridership is shown by its current record daily ridership of 583,000. The more the ridership, the more commuters are served daily. For the investor, it means more profit. This should attract investors to finance ART under the PPP program of the government. In the following slides, we will show photos of the 21 monorails to give viewers an idea of how a monorail system looks like and the infrastructure needed for its operation. We start with Bangkok, Moscow, Russia, Dubai, UAE, Kuala Lumpur, Malaysia, Mumbai, India, Daegu, South Korea, Sao Paulo, Brazil, Ashgabat, Turkmenistan, Bologna, Italy, Sentosa, Singapore, Wuhu, China, Chongqing, China. The following are 4 monorails in the USA: Jacksonville, Florida, Seattle, Washington, Newark, New Jersey, and Las Vegas, Nevada. The following are 5 monorails in Japan: Kitakyushu, Tamatoshi, Naha, Haneda, Tokyo, and Osaka. This slide will show the major advantages of LRT over monorail: higher capacity, better profitability, and easier deboarding during total breakdown. The same slide will show the major advantages of monorail over LRT: lesser construction cost, lesser noise, tires are rubber instead of steel as in an LRT, and lesser visual pollution. These advantages are the reasons monorail is chosen instead of LRT in some cities. In an LRT, the combined track is massive and full width. It darkens the skyline along its route. In a monorail, the tracks are thin and separated. There is a gap between parallel tracks. ART has so many advantages over LRT and monorail. This will be elaborated in other chapter videos. An example here is in the aspect of visual pollution and construction cost. An LRT causes heavy visual pollution along its route. A monorail causes moderate visual pollution along its route. An ART causes very minimal pollution along its route. The more concrete and steel that is needed to build the columns and tracks to support the traveling passenger vehicles, the higher the construction costs. Obviously, the LRT is the most expensive. Monorail is next, and ART is the cheapest to build. This is a list of 21 currently operating urban monorails in 21 cities all over the world. The monorails in the list are from 1962 up to 2023, a period of 61 years. Photos of the listed monorails have been previously shown. This is a list of 38 currently operating urban ARTs around the world. The ARTs on the list are from 2004 up to 2023, a period of only 19 years. Videos of the 38 ARTs in operation are shown in another chapter video, as shown in this title page. MOA Edsa Taft Alignment Views. This is a map showing the MOA Edsa Taft ART line. The ART line is very easy and quick to install. Between MOA and Rojas Boulevard, the ART can easily fly over all buildings. The maximum height of most of the buildings in the Asiana complex is only 15 stories. Between Rojas Boulevard and Edsa Taft, the ART will only traverse Edsa Avenue. This is an aerial view of the ART line. The towers to support the cables can be placed on the sidewalks or on the center islands. This is an approximate view of the ART alignment that starts from MOA flying over 15-story buildings towards Edsa Taft. These two towers are placed on top of the sidewalk, while this tower is placed on top of the center island. This is a clearer photographic view of the surroundings of the ART. The passengers will have a spectacular view of Pasay City and its surroundings at a height of up to 5 to 15 stories along its route. Travel time between MOA and Edsa Taft will only be 5 minutes. There is no waiting time to get a ride. This compares to a jeepney or bus ride of 30 minutes, including waiting time. At the Edsa Taft station, the ART will directly connect to the LRT1 and MRT3 lines through a passenger tube. It will be similar to this elevated passenger tube of the ART in La Paz, Bolivia. This is the passenger tube that connects the light blue ART line to another connecting mode of mass transport. Direct transfer by an ART passenger to LRT1 and MRT3 will take an average of 2 to 3 minutes. This is the view of the ART station at MOA, north of the SM Globe. Front view of the MOA ART station. The ART station will be provided with an open-air terminal facility for connecting modes of transport. Close-up views of taxis. Close-up view of motorcycles, bicycles, and electric scooters. Modernized jeepneys and partner buses. The travel from MOA to Rojas Boulevard will not be along Edsa. It will be on the left side, flying over up to 15-story buildings towards Edsa Taft. Tower foundations will be on top of sidewalks. This is the vehicle flyover at the intersection of Edsa and Rojas Boulevard. From here, the travel path will no longer be above buildings. It will be along and above Edsa Avenue. Tower foundations will be on top of center islands or sidewalks. This is a covered unloading and loading area along a pocket lane. There will be a similar unloading and loading area on the opposite side of Edsa Avenue. Shown here is a terminal facility similar to that of the MOA ART station. These are for jeepneys, buses, motorcycles, taxis, bicycles, and electric scooters. A passenger tube somewhere here connects this ART station to both sides of LRT1 along Taft Avenue. There is already an existing passenger tube from LRT1 to MRT3. The simulation has shown that ART has a shorter travel distance compared to a monorail. The ART needs only to travel 1.8 kilometers in a straight line, whereas the monorail needs to travel 1.9 kilometers in a curvy line. Additionally, in an ART, there is zero waiting time as cabins are always available for a ride at the passenger platform. In a monorail, passengers usually wait between 3 to 10 minutes before they can get a ride. Thus, even if an ART travels slower, in most cases, it can provide a shorter travel time for passengers.